Thank you, Professor Raju. It's a pleasure to be here to talk to university folks. Whenever I hang out with intellectuals, I learn something. So my objective today is to share with you a little bit of what I know on the subject of NDE 4.0 and solicit certain intriguing, curious questions from you guys so that I can go back and think, what do I have to do next? Along with me, I have a partner, Johannes Rana, who's in Germany. He and I have been on this subject for a few years now. Unfortunately, he's not here at the moment. I do not see him on the Zoom, but if he shows up, he will swing in to say hello. Now, a little bit more about me. I think Professor Raju covered very well what I did, but I just want to share with you that I have a diversity in my career. I used to be a professor at one time. Then I worked for small business. Then I worked for Fortune 500 companies. And since 2014, I'm a freelance innovation coach. But I didn't know what to do with all the learning I had, but to share it with as many people as I could. And the only way to do that was to either I go become a professor or I become a freelance coach. So I started my coaching practice. And that has taken me around the world. In 2018, I met Johannes Rana from Germany, and we started this subject of NDE 4.0, which is non-destructive evaluation in the fourth industrial revolution. So we have collected certain literature, we created some research publications, we have a handbook coming out in a few months. We recently published a book on NDE 4.0. This subject has really enriched me and Johannes and a few other people in the community who are at the forefront of digital transformation. My focus now is why, what, and how. Why should we pursue this? How should we pursue this? And what does it take to bring digital transformation into the inspection world? So I will actually share all of these three things with you today, plus a bit of a flavor around the role of humans in this entire thing. While we talk about automation and robotics and Industry 4.0 and Internet of Things and all that stuff, but humans have a significant role to play. So I will touch upon that as well. Professor Raju said that I should share with you what I have published. So in the last few years, I've got a few books that have come out, mainly on innovation and applied innovation, human factors in innovation, and now one on the subject of that I'm talking to you today. I actually don't mind promoting these books as well because I don't take any royalties. Whatever money comes from these books, I donate that for ocean cleanup because that's one of the purposes that I have for my business towards a sustainable planet. So let's start with the NDE 4.0. I'll give you a brief introduction as to what the subject is all about. Then I'll talk about why, what, and how. Starting with the introduction. I think by now, everybody is familiar with what is Industry 4.0. Since I can't see you, I will assume that it's okay to give a 30-second introduction as to what the fourth industrial revolution is all about. See, the first revolution happened in the late 18th century when humans, science, discovered the power of steam and mechanization started to take place. But real mechanization happened when we invented electricity. That created ability for mass production, have assembly lines. That brought us to a situation where we really got a handle on materials. The third revolution, which is towards the later part of 20th century, happened because of computers. Automation, robotics, electronics, things started to become digital in nature. We learned how to deal with information. The fourth revolution is now happening, is essentially a merger of second and third. Okay? The way I put it is, the second revolution, we became masters of the physical world. The third revolution, we became masters of the digital world. And in the fourth revolution, we are now developing mastery of digital and the physical world together. We want to be able to go from physical reality to the digital environment and come back to the physical environment. Have a closed loop. Have a cyber physical environment. That's what the fourth revolution is all about. Sometimes you would hear people saying, oh, we've been doing simulations for 20 years. We've been doing 3D printing for 15 years. So we have been in Industry 4.0 for 20 years. Well, they just told you that they don't understand what Industry 4.0 is all about. It's not about digitization. It's about digital transformation. As we go through this lecture for the next 45 minutes, some of these aspects will become clear. If not, it's okay to go dig deeper, learn a little bit more until you begin to realize why is it so different than just being able to do computer simulations or just being able to do 3D printing. You may also hear terms like Industry 5.0. There are guys out there who started touting about Industry 5.0 saying, we've been doing 4.0 for a long time. Well, this is how I look at it. If they're coming from a research environment, a university or a national lab, and they're trying to explore what would be the next big thing beyond digital physical, I'm listening and I'm learning. But if they come from industrial sector, they're just marketing. They're just trying to show, I know more than the rest of the world, please talk to me. Okay, those are the guys who put me off because they haven't yet probably even understood 4.0 to go talk about 5.0. So be careful when you hear 5.0. So the fundamental difference, like I mentioned, is that this 4.0 means you go from physical world into the digital world, do your analysis, processing, simulation over there, predict what will happen to the physical world, decide what should happen in the physical world, and close the loop. And when it comes to the subject of inspection, the physical world and the physical inspection techniques, whether it is ultrasonic or eddy current, is still the same, but the digital piece is continuously developing. And that's what differentiates 4 from 3. Let's talk about briefly the technology portfolio of 4.0. When it first came out, there were 5, then it became 9, then it became 14. In 2020, the list has grown to 17. And I don't know, there may be another 2 that came up in the last 6 months that I have not followed up. But the point is that the technology portfolio is continuously growing. There is no boundary on it as of now as to this is it, okay? So whenever you come across new technology, which is digital, but it interacts with the physical reality, it would belong to this portfolio of Industry 4.0. Within NDE world, any inspection system may or may not use all of them. It may use only one thing, it may use 2 things, it may just use augmented reality or artificial intelligence or IoT. But as a ecosystem of inspections, somewhere along the business, along the value stream, all of these technologies play a role. Let's look at what we mean by revolutions in the inspection sector, in the inspection world. It's a little different than revolutions in the industry. You see, in industry, we define revolutions by power of steam, power of electricity, power of computers, and now power of network. Because each one of them changed the game. In the inspection world, prehistoric times, humans have used their 5 basic senses for inspection: sight, hearing, smell, touch, taste. That's how we have done. Even now, a child that is born, that's how a child perceives the world around it. To look for cracks, you could see them on the surface. You could hear things breaking. But that was not called non-destructive inspection because there was no procedure behind it. There was no periodicity. There was no cycle behind it. When that became a systemic process to assure safety, then we started looking at mechanisms to highlight the surface. A dye penetrant, a magnetic particle, using magnification lens, using stethoscope. All of those little devices, they amplify whatever is on the surface and still allows human senses to be able to see on the surface. So that was really the first structured way of inspecting. Then the need came to look beyond the surface, to look deeper inside. We came up with techniques like ultrasonic, eddy current, X-ray. So that's a revolution now, because now you can see and hear things which are not on the surface, but are hidden. The third revolution actually does tie with the information world. You go from X-ray to digital X-ray. Now you can share the data, now you can email it, you can superimpose multiple things, you can do lots of analysis on it. It again revolutionized how we handle the information about possible damage, which is hidden behind the surface. So that's like the third revolution in NDE. The fourth revolution that is happening now is around creating an intelligent foresight, which means in addition to seeing what is happening behind the wall in space, I want to be able to see what will happen in time. If I keep using this part the way I've been using it, how long will it last? How will it behave in future? Can I go from just seeing in three-dimensional space to actually seeing in time? Can I predict the future? You remember how sometimes parents know that a child who's playing dangerously on a swing or is about to fall? It's the mother's sixth sense that the child is about to fall and goes and creates a protective environment for the kid to play safely. You know how some of the experienced professors and inspectors are able to predict what will happen in the future, in the near future? That's like the sixth sense. So we are saying we can actually bring sixth sense to an inspector and to a machine through Industry 4.0. And that's the revolution that I'm talking about. The next revolution in inspection is to be able to see beyond today. I can take a snapshot and I can see what is wrong with the system today, but I can also analyze it in a manner to see what will be wrong with this system tomorrow and day after. Intelligent foresight. So that's the overall introduction to the topic of NDE 4.0. Now let me share with you why we want to do it. I think by now it is clear why. It's because of safety. We do not want accidents of this type. Actually, my career started in the 1986 and 7, 88, pretty much when this accident happened. And that's how I got into the subject of damage tolerance, inspections, crack simulation, human factors, anything and everything to do with aviation safety is what I've been doing for the last 30 years. This is the motivation. We do not want critical infrastructure to fail. Airplanes, railways, nuclear power plants, bridges, whatever you think of, space station. We want critical infrastructure to stay safe. That's the motivation. More recent accident, same thing. We need a good non-destructive evaluation, good non-destructive testing capability to prevent failures. There are a couple of other things we want to do. Think about steam boilers. Here are inspectors in this very difficult environment performing inspections. Today, if I have a robot or if I have a drone and I put it in there, I can make the job easier and safer for the inspectors. So that's another reason why we want more automation, more intelligence with inspection devices. Essentially, we want to address safety issues but we also want to pursue business value. We want this thing to be financially viable. We want the assets to last longer and safer and provide service to the extent possible so that it makes aging infrastructure affordable. So you want to drive safety, but you also want to drive economic value. That's the purpose of NDE 4.0. Looking at it from safety perspective, I would also like to share with you how the revolutions in safety assurance have been. And I think engineering community knows some of these terms very well. Okay? Factor of safety. That's what we used to do 100 years ago. In a sense, that was assurance without destroying. Then when we learned a little bit more about materials, we moved on to the concept of safe line and fail safe. We call it preventive maintenance. Then we understood the subject of damage tolerance, where I can predict the crack growth, allow a structure to live with cracks up to a certain level. NDE was important all through. And that damage tolerance based philosophy took us to what we call as predictive maintenance. Now I can predict for how many hours is this airplane safe, for how many days is this bridge safe, and I'll maintain accordingly. With 4.0, we can go to what we call now as prescriptive handling. It's just like a doctor-patient. Doctor doesn't say that everybody should have the same medicine. Doctor prescribes the medicine for that individual, for that patient. We should be able to prescribe maintenance plan for every individual asset, for every airplane by tail number, for every engine, for every car, for every train, for every bridge. We should be able to handle it by the asset so that we can optimize the economic value. That's the power of NDE 4.0. That's the power of data once you start collecting it and figure out a way to handle it, analyze it, and use it to predict. One of the other things we want to understand is, people who have managed projects or otherwise as engineers, in any system, if you're looking for things like faster, cheaper, better, you're looking for quality, safety, cost, speed, availability, you really can't get them all. You can only pick and choose two of them, and the third one is determined based on what you want out of those two. Think about it. If there's a project, you want that project to be done in a certain time and a certain quality, you have to pay for it. If you have time and money constraints, you have to sacrifice quality. So like that, any evolution that we do, any project that we manage, has to kind of compromise between safety, quality, cost, speed, and all that. But one beautiful thing about revolution is it is changing the game so fast, and it's bringing in new paradigms that for a period of time, while you are in transition, while you are actually making the changeover, you can get all three. And NDE 4 today is at that stage where we can deploy and expect safety, cost benefit, speed, all of them together. This will not last for very long. Once the digital transformation is fully adopted, then again, we'll get into a situation where we have to give up one of these three. But for now, for the next 5 years, we can actually pursue projects and technologies in a manner to get benefit on all three accounts. There are lots of other use cases. I probably will skip the details over here, and I don't want to read the charts, but there are a lot of use cases for how the NDE data can be used in Industry 4.0 and how Industry 4.0 technologies can be used in the inspection world. And one interesting thing is that very soon, the inspectors will have a renewed respect for the profession. As of now, most businesses tend to treat inspectors as an unnecessary cost, as something as a burden, but that's about to change with NDE 4.0 because suddenly the data being generated by the inspector has value more than safety assurance. It has value towards product quality. It has value towards cost and economics. So we are at the verge of transition where suddenly this particular profession of NDE will have a renewed sense of respect. And it all boils down to because of the data we create. Let me share with you a simple concept and what the sixth sense can do. I'm not sure how many of you actually understand, if you're in the NDE world, you understand the concept of probability of detection. If not, I'll quickly give you an anecdote. You know how sometimes you go to the kitchen and you're looking for a pizza cutter and you can't find it, and then you call your mom or wife or sister or whoever is at home, say, I can't find the pizza cutter. And she comes over, opens the drawer, and pizza cutter was there in the drawer. You just missed seeing it. That's probability of detection. If an inspector is searching for a crack in a structural element, or if a doctor is looking at your X-ray of your bone, there is a probability that the doctor will see the crack, and there's a probability the doctor will miss the crack even if it is there. It's never zero and it's never one. It's more of a curve that goes something like this. And typically, there is a thing called intrinsic capability of the equipment, of the X-ray equipment, for example, which says that there's a 90% probability that this equipment will find a crack of a certain size. And this particular number is what is used in all sorts of inspection and maintenance programs and things like that. But it really is a full curve. It goes from a little bit more than 0, 0, getting close to 1. Even if the equipment has a certain capability, the inspector who's using the equipment or the doctor who's looking at the X-ray has got certain human factors. And sometimes, even though equipment picks it, the human eye misses it. You could have an X-ray sheet in front of you and there's a little crack that's visible. It's on the X-ray film or the digital mode, but as a radiologist, you can still miss it. And the human factors reduce the reliability of the system. And we end up in a situation where we must say, okay, 90% probability of detection with 95% confidence. And that's called the 90-95 crack size. And now suddenly you have a situation where you can't really use the equipment to its full capability. You have to plan around its reliability, not the capability. So you cannot go by the smallest it can find. You have to go by the largest it will miss. And this gap, if I can eliminate this gap through robotics, through automation, stuff like that, then I have an opportunity to do better in field. But one thing that happens with NDE 4.0 is that the digital data from multiple assets over a period of time can be fed into an AI machine learning algorithm, which can start pushing the curve even beyond the green to what I call as, it's the digital twin. It's the sixth sense that's coming in, that's sharing with you the ability to detect cracks, which the machine alone was not able to see on this particular asset and this particular artifact. And that's the possibility that suddenly NDE 4 opens up for the real world to take advantage. This whole concept has been briefly proven by a couple of guys in Europe. His name is Ika. He has deployed artificial intelligence and he has pushed the red curve back to green. And now he's working to push the green curve back to the blue to develop that sixth sense. So that's the value of NDE 4.0. Safety solutions and economics, both. So up until now, we have been paying for safety. You have to spend money to assure safety of an airplane. You have to spend money to assure safety of a bridge. NDE 4 can get to a point where you spend money to assure safety, but you also get so much data that can be converted into value so that at the end of the day, you assure safety and you also create economic wealth. That's the power. That's the beauty we want to bring about. That's the vision of this particular subject. And it's going to come from the same digital twin that I will use for economics and for technology. So that's why we ought to pursue NDE 4.0. Now let's talk about what. Yes, robotics. It's already there. It's being used for many years. It's 3.0. It's not 4.0. Even when we get into drones, it's still 3.0 if it's programmed. But if drone gets into an environment and begins to understand the environment and creates its own path to fly through hazardous area, do the inspections, and go back in to further zoom into areas that became suspicious, it becomes NDE 4.0. If it's a programmed robot, like here on the left side, it's not 4.0, it's just robotics, it's 3.0. Think about artificial intelligence. Human eye can look at a picture and you have to figure out signal from the noise. But an AI can look at multiple dimensions, and if it has past data, or if it has multiple snapshots over a period of time, it can actually decipher noise from the signal, even when the noise levels are below, even when the signal levels are below the noise levels. So you can actually have enhanced capability with AI to pick damage from visual pictures or from other mechanism, whether it's ultrasonic or eddy current, any other way of creating digital signals. It can suppress the noise, which otherwise is very difficult to do. That technology is also coming. Is it NDE 4.0? In some sense, yes, but I'm still kind of not completely on that. And me and Johannes argue about that back and forth. But jury is out and we'll figure it out. In the end, actually, it's not important whether it is 3.0, 3.5, or 4.0. As long as it generates economic value and safety, I'm happy to take it as 4.0. What about augmented reality? We can now have inspectors being given work instructions just in time on the asset to go do this, go fix this. We can train inspectors differently. Inspectors can visualize anomalies on your iPad or on your digital environment where the anomalies are being picked up by some other sensors but superimposed on to the system. Just like your NBA games or your football games, there is so much augmented reality. You see all those lines and you see all those markers on the ground. They're not on the ground. They are being projected to you. That's augmented reality. And that is actually very good because it's merging physical and digital world and bringing to you in a digital form that you interpret as physical. So that's 4.0. And that is very, very useful for any context in the industry, whether it's manufacturing or inspection or just education training. A drone that goes inspection, we just talked about it. I may even have a video that I would like to show you here. So this one is now performing inspection inside a closed chamber, is able to find its way, bounces around, figures out where to go, balances itself, captures the data, and sends the data back, right? It's interacting with the physical world. It's using the digital data to interact with the physical world and control its physical movements to capture physical data. That's NDE 4.0. Tomorrow, will we have one flying machine inspecting another flying machine? Absolutely, yes. We are getting to a point where a small little bug can go around an airplane and do the inspections. Will that be 4.0? Absolutely, yes. Let me share with you what classifies as 4.0 and what could be left out. So we talked about non-destructive evaluation, and we talked about Industry 4.0 with all these technologies around augmented reality, artificial intelligence, robotics, all that. If I bring NDE to Industry 4.0, applying the previous generation of inspection equipment to a 3D printed part, and you're still doing manual but digital quality inspection. I do not consider that to be NDE 4.0. But I have colleagues who say, well, I'm using this, so it's NDE 4.0. We can debate that. I leave it open. I do not count that as 4.0, but I'll leave it open. On the other side, if I were to take digital technologies into the NDE world, for example, I'm inspecting bridges with sensors. There are multiple sensors that are under the bridge, but then the data is being acquired by the inspection truck that moves back and forth and presents a signal back to the driver and say, hey, you can turn around and we need to re-inspect. Or who knows, tomorrow this truck could be autonomous and the sensors will decide where the truck should go to do the inspection. Wonderful. So that is digitalization of NDE 4.0. And that is getting very close to NDE 4.0. It's still not digital transformation. Digital transformation is when NDE and Industry 4.0 both are working simultaneously. They are both working simultaneously. Something like an automated X-ray alongside an autonomous manufacturing cell. The whole thing is completely automated. The entire system is fully digitally transformed. That is true digital transformation of inspection systems. So those are the three facets of NDE 4.0 that I wanted to share with you. So how do we define it? The definition that 15, 20 of us from international community have come together when we propose that NDE 4.0 is a cyber physical non-destructive evaluation, which comes out of confluence of Industry 4.0 digital technologies with physical inspection methods and business models. 2, enhance inspection performance, integrity, decision-making for safety, sustainability, quality, as well as provide relevant data required to improve design, production, and maintenance. You see, one of the things that happens is if 20 people get in a room to make a definition, it usually becomes this big. And we are okay with it because this is the most comprehensive single definition, which captures the what, the how, and the why of NDE 4.0. It leaves nothing open to interpretation. But a simpler one for everyday use is, it's a convergence of NDE and Industry 4.0 for safety and economic value. That's it. If you say inspection methods and digital technologies come together for safety and economic value, we've got NDE 4.0. That is a simpler, easy to communicate, easy to understand definition. Hopefully I'm making sense. Let's talk about where this is taking us. So I talked about predictive things. So imagine a digital twin for a particular aircraft asset. For that asset number, we have complete digital data all the way from its manufacturing, and it captures all of in-service inspections. And then every time you do an inspection, you can visualize the data through augmented reality. You can run simulations. You can predict where the damage would grow. You can use artificial intelligence and even run what-if scenarios. All that leads to creating a prescription for the asset, which says, do this, don't do this, maintain this, repair this. You need 3D printed spares. You need some kind of an edge computing to control something. This is how a digital twin and a human in the loop can together prescribe what happens to sustain that asset, to assure its safety, reliability, and affordability. It takes you from physical world to cyber world to human intervention and back to the physical world. It converts NDE from a cost center, spending money to assure safety, to value creation through data that we already talked about a few minutes ago. That's what we call as prescriptive NDE for individual assets. Now it's like a doctor taking care of each patient separately by prescribing medicines and diet and healthcare directives for that individual. We can do the same thing for expensive assets. But to be able to do that, we have to view NDE 4 as an ecosystem, and that ecosystem revolves around the asset. The four primary stakeholders in the ecosystem are the person who built the airplane, the asset OEM, could be Airbus, could be Boeing, the owner operator, Delta Airlines, Air France, whatever, who's operating it, the inspector, the guy like me who's performing the inspection, looking for cracks in the airplane wing or in the engine or wherever, and the NDE OEM, the company that built that ultrasonic machine, the company that built the X-ray machine. These are the four primary stakeholders that must be involved in creating NDE 4 ecosystem. Plus, there are others who support universities, training schools, the regulation bodies, certification bodies, and then people like me who flap our jaws and give lots of lectures and try to create some buzz around what's going on. We are a part of the same ecosystem. We hope that we are adding value, but truly we are an insignificant influence in this entire ecosystem. The whole idea is each entity must understand why they should do NDE 4.0, what's important to them, and how can they contribute. But then you must understand and behave as a single system. Data has to become the environment. That's the trick. Unless until all of these entities start living, breathing, eating, spitting data, this will not be successful. And that's why a digital twin of the physical asset is very important. And that digital twin belongs to the ecosystem. And this ecosystem drives a mutual dependence. Now, suddenly, each one of us in this ecosystem are dependent upon other person, upon other organization to create data, to consume data, to help make decisions to assure safety. This is the power of NDE 4. I'll actually skip this particular detail here. I think it's running a little bit over time here. So I'll take you to what NDE 4 does to you is it takes you from understanding what happened, why did it happen, what will happen, to what don't we know. It can really raise our ability to analyze data in a hierarchical fashion. Essentially, an inspector in the NDE 4 ecosystem will be able to detect an anomaly on the digital twin. Remember the digital twin? It's the virtual representation of the physical world. Up until now, inspector is inspecting the physical world and looking for damages on the physical world. But now with NDE 4.0, inspector is actually observing the digital twin and looking for damage on the digital twin, which is using this physical data plus the data from previous inspections, plus the data from other assets it has learned over a period of time. So an inspector in the NDE 4 ecosystem will be able to detect an anomaly on a digital twin before the inspector can pick it up on a physical asset or instrument in today's system. It's almost like, think about it, people ask question, will AI replace my doctor? Well, the answer is AI may not replace your doctor in the near future, but a doctor with AI will replace the doctor without AI. So the same thing will happen here too. An inspector with AI, an inspector working in NDE 4 system will replace the inspector who's still working in a previous system. Because within the 4.0 environment, he's able to detect anomalies which were earlier not possible. That's the power of, that's what I call as bringing sixth sense into the system, bringing sixth sense to younger inspectors, bringing the value of hundreds of years of experience from multiple inspectors through artificial intelligence towards for use by every inspector in the ecosystem. That's the power of NDE 4.0. How do we pursue it? Well, Industry 4.0 gave us 4 principles. So we actually translated those principles into the inspection world, and they can be easily ported. So we just said, okay, if there are principles for Industry 4.0, I'll take them towards NDE 4.0 and I'll apply those principles. And they work wonderfully. So we've translated all 4 of them, and they apply as easily, both in terms of transparency, technical assistance, decentralization, connectivity, information technology. So that's how you go on, how you develop the technologies. But the important piece is to understand the problem you are trying to solve. For an inspector, what does he want? An inspector wants to work easy. He wants to be comfortable, clean, no consumables, easy to interpret data. He wants zero job pain. I want to be able to do my job, everyday job, as easily as possible. What does the boss of the inspector want? He wants to keep flying the airplane all the time. He does not want to shut down the railway bridge and not have any trains go by for 24 hours. He wants to have minimum inspections. He wants to save money. But he also wants reliable information. And then he's the one who has to take decisions. So he wants all the information he needs so that he can be decisive. But if you quietly ask him on the side what you want, he will tell you that I want zero inspections. I don't want inspections at all. It's a cost. It's a problem. NDE 4 can actually address both. It can take you towards a cleaner, simpler inspection, and it can also help the manager be decisive. This is getting to a point where multiple stakeholders, which up until now had conflicting requirements, can now get both of them together at the same time. And you just have to figure out which of these technologies will address the pain of the inspector and the pain of the business manager. You pick those technologies and you take them through a simple process of developing it into a product. So once you've got the customer insight, this is what the inspector wants, this is what the manager wants, you go through the ideation in terms of what technologies will help you. You go through value proposition, which means it does solve the problem for both the inspector and the boss. And then you qualify the concept. Does it make business sense? Does it have ROI? If I were to invest in developing this product and sell it, can I do it profitably? And if you're able to produce something, a product, a service, and bring it to market for profit, you have a solution. Go run that as a project. Most of the time, you have to generate hundreds of ideas to come up with few things that make sense, and then very few that make business sense, and then only some of the projects are actually successful. So it becomes more like a filter. And you have to go through that filter. There is no other choice. There is no better way to evaluate ideas than to actually test it by creating a product and doing it in the lab and in the field, and then testing it out in the market. So from idea generation to money making, you can follow a disciplined process to bring these technologies from fantasy to reality. There are lots of other challenges in this. The technology is still evolving. We don't know, it's just like late 80s, late 70s, early 80s with the internet. It took so long until HTML came. It wasn't very popular. So technology, interfaces, standardization, we're still working at it. Workforce development, digital skills becoming a lot more important. And we don't have enough of those. So if any of you are thinking what skill to develop, I will tell you, read about Industry 4.0, look at careers on data science, and see how that blends with whatever core discipline of engineering or science you are pursuing. Ethics is another major issue. We haven't fully understood the subject of ethics when it comes to artificial intelligence or the fourth revolution. The leadership style is changing. The leadership in the digital transformation world is very different. You have to go away from hierarchy. You have to accept that competition is unpredictable. You have to accept significant amount of ambiguity in technology development. And all these technologies also have a challenge of workplace acceptance. Just because technology is good does not mean that people on the shop floor or the inspectors in the real world will take it. There's a lot of friction and inertia in adoption of new technologies. And then there are some unknown human factors. We don't know how it will behave. We don't know how people will behave when a robot becomes their boss. I had a recent experience. About 3 months ago, I worked with an AI agent to do some research, and it was very unnerving the rate at which this artificial intelligence was generating ideas and giving me suggestions. Well, we actually published a paper with AI as a co-author. That's the first paper in a peer-reviewed international journal where my co-author is an artificial intelligence. And I'll tell you, that experience was nerve-wracking for first 2 weeks. But then I had to adapt. I had to say, okay, think about it. It's not machine, it's human. And then I could reconcile. If this were a human, it would be okay with that. Just because it is coming from a machine, I'm nervous. But yeah, the speed and the magnanimity and the breadth of data that AI brought forward was completely mind-boggling. Just to put you in perspective, it took me 2 weeks to define the problem, 1 week to solve the problem in partnership with AI, 1 week to write the paper, and the AI even wrote half the paper and wrote the abstract. And once I submitted it to a journal saying AI is a co-author, they accelerated the review process. We defined the problem in June. It was published in the journal by end of August. That was also very nerve-wracking for me to see in 3 months, we could go from an idea to a published paper. So, how humans will interact with machine, we're going to create new problems. And as of now, we can only speculate certain psychological issues with that, but we have to deal with it as they come. So it's a journey. Anybody who wants to get into digital transformation, it will take multiple steps. It will take a few years. It's full of uncertainty and ambiguity. You all will see more change in your lifetime than the previous 4 generations have seen, or maybe 5. It's completely mind-boggling when you start throwing biological agents into this digital physical world. What can that do? But one way is we have to work on this together. I've always said, when you have a situation like this and you're looking through revolution, together is better. But in the last 2 years, when I start thinking about ecosystem, and I'm thinking you actually have to go from ego system to ecosystem, leave your personal ego aside and get into data sharing and work towards ecosystem. I'm actually more and more convinced that together is the only way going forward. Working alone by ourselves within our organization, within our industry, will not take us very far. We will be left behind. Together is the only way. So that's how you pursue. Use your systems, use your processes, use your technologies, exploration, experimentation, all that, but work together. And in that spirit, we've been doing lots of things together. So to summarize, within NDE 4.0, the takeaways are, it's about digital and physical coming together. It's about driving safety and economic value together. It's about using a process, having a community, and leveraging NDE 4 technologies in itself to help us grow and evolve or revolutionize, and view it as a transformation journey. That's the way to do it. Okay. So within NDE 4, we have this special interest group. ICNDT is International Committee for Non-Destructive Testing. So these are all the member countries that we have brought together. And we are now creating guidelines on how to globally lead this transformation of NDE from 3.0 to 4.0. We have lots of documents coming. We have a YouTube channel. We have a LinkedIn page. The community continues to build. The handbook is coming out in January. This has got 78 contributors from 10 different countries. It'll be available through Springer and through Amazon. We just published a book, NDE 4.0, and we are also creating a small document like an ISO style guidance as to how to go about doing this transformation, which any company, small, medium, large, whether you're developing inspection equipment or you're developing new airplanes, you should be able to use that document to guide you through this journey. That's where we stand. And I always close my talk with this saying, if you want to be a leader, you need a chief innovation officer, somebody who will drive innovation. If you want to be a follower, you need a chief risk officer. You need to really focus on how much risk you are taking by either not following or following the wrong person or wrong technology or wrong entity. Either way, you're actually doing something. But if you become an observer and you say, I'm just going to wait and watch and not do much, then I think you better start praying, because this train is fast and furious. It will not wait for you. It will actually run you over. So with that, I would say NDE 4, thank you very much. Let the journey begin. Anybody interested in this, look us up, LinkedIn, YouTube channel. We are here. We are building the community globally. You're welcome to join us. Back to you, Dr. Raju, and I'm open for any more questions. We do have a few more minutes.
Okay, yeah. Thank you for a very interesting lecture. And questions, please? Anybody has questions?
Come on. Hey,
yeah,
guys.
come on.
Yeah, students, 23. I want 2 or 3 good questions.
Well, let me start with one question.
Okay.
How does the NDE 4 apply in medical field?
The fundamentals are the same. The difference is the artifact you're checking has now a biological aspect, so you have a lot more variation from subject to subject, right? So yeah. The AI will be a lot more stressed. I think AI is already getting into digital radiography piece of it. Same thing with the digital ultrasonic. The fundamentals are same. The uncertainty band is a little bit broader than as compared to metal parts, because you're dealing with a biological variation from patient to patient.
We have a question in the chat.
Yeah.
It's from David Hollinger. It says, your opening slide, you said you had 10 plus failures. Can you share with us your favorite failure or a failure that you learned the most from?
Yes, absolutely. I shouldn't say my first, I think I failed many times. Actually, I just said 10 plus because I don't want to expose all my failures. The largest one was in 1996, along with a bunch of grad students at Indian Institute of Science, where I was a professor. We wanted to build a drone that would carry food from one end of the campus to another end of the campus. Remember, this is 25 years ago now, 96, yes. And we designed a beautiful helicopter type thing with twin rotors. We built it. We could not balance the rotors. We failed miserably, and we tried all sorts of technologies. One batch of students graduated, couldn't fly it. Second batch of students came. They tried a whole lot of things. We could not fly it. So that was one technology failure we had. The second failure that I had in my career was when I actually tried to create something what we call now a digital twin for airplane maintenance at fleet level. This was in early 2000, and we had a fantastic product, and we went about trying to market and sell it, and we failed in the marketplace because we did not understand very well the human adoption cycle to the technology. We did not realize that information is power to a point where people actually, even if they know that this database will help the organization, they would not adopt it because it would not help them personally and it would hurt them at that point. So we had that failure, and that lesson even haunts me today with this NDE 4 philosophy that I want to bring in. And that's why I say, we got to go away from ecosystem to ecosystem, but it's very, very hard to break. So that lesson is the second one that I would share. I have a few other failures, but I think 2 is enough for today.
I also had a question. I followed when you talked about at the end of your presentation about an AI software helping you in your approach to solving the problem. But then you said the AI also helped you write the paper. So could you comment on, I envisioned that also the AI was iterating drafts with you on the paper, but I don't think that's maybe what you meant. What did you mean when you said it helped you write the paper?
So it's very interesting. We first, have you heard of the agent called GPT-3?
Uh,
I have not.
No.
GPT-3, it's coming from this company called OpenAI. It's a generative pre-transformer. It's the most powerful language-based AI at the moment. It has access to all of Wikipedia and a whole lot of other public domain. And any question you ask, it crawls through Google. Just like I were to do as research using keyword on Google, that GPT-3 can do that, and also search for keywords on Wikipedia and actually compile the context and content. So we asked GPT-3 that I want to write an essay on human factors in decision making. Irony of it, this is the paper we wrote that with AI, the topic was actually human factors. So AI writing about human biases, that's the intriguing aspect of the whole thing. But we asked it, if you want to write an essay, give us a table of contents. It generated a table of contents, including introduction, approach, blah, 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 conclusions, and everything. Then we picked pieces and we said, I want some more content on this particular thing. We gave it context, and we also gave it the sensitivity as to how deep and broad we want it to be. And it brought back paragraphs after paragraphs, written very well. We put those paragraphs in there, we created the thing, we created our own content, we put the whole thing, and we threw it back at GPT-3, asking it to generate an abstract, and it gave me an abstract. And we put that abstract as is for the paper. I'll be happy to email that paper to you. I'll do that afterwards. So that's the power that AI did for us.
Given that at this point in time that you were able to do that, I could see a scenario a few years into the future where we have to worry about scientists and faculty members creating papers that they really had no contribution to, and then we're going to have to develop software to check papers for original human content.
That's a good point.
And the AI might figure out a way to flag that out, or it might figure out a way to
the AI,
manner.
exactly, develop software to figure out how to get around that, because we have pretty sophisticated software that will check your paper against the whole database of publications in the world for plagiarism.
Yeah.
I've unfortunately gotten caught borrowing paragraphs from my own papers, and then it will highlight and say, oh, you had 20% of your paper was already appeared somewhere, and well, that was introductions and references I had used in other papers, and so it's pretty darn good software for catching plagiarism.
Yeah. I use that all the time, and we ran this paper we wrote with AI through that, and nothing flagged up. Very interesting. We also pitched the outcome of this particular GPT-3 AI against another AI tool that works with Microsoft Word, the Pro Writing Aid, which checks you for English grammar and stuff. And interestingly, the content created by one AI was not very much liked by the other AI. The Pro Writing Aid started picking on it, saying, you have too many repeat words, you have too many repeat sentences, because every paragraph starts with the same line. So we also observed a few other things about one AI critiquing another AI.
That's funny. Yeah, I think that's very much in our future, given the power of these tools. So
yeah, it is. In fact, the OpenAI people have now extended the GPT-3 to an image and video version of it, and it seems like we are getting to a point where, even the movies, you may not have to make the entire movie. You just make the first 20% of it, and you let AI learn it, and you throw the context of the rest of it, and the damn thing will generate the movie. Who knows? I mean, how much art is going to become computerized? It's just, sometimes it's scary, sometimes it's inspiring.
Well, your AI can also implement your NDE 4.0 strategies too.
It could, yes. It could create strategies. It could actually develop strategies for us, inspection plans for us. Part of the prescription could be that it just re-prescribes and it learns and it says, this is what you need to do.
On your slide with the books, you had the bottle multivitamins of NDE 4. Can you elaborate on that?
I caught that one too. I forgot to ask about that.
Can you elaborate on that?
Yeah, I can. I'll pull that up for everyone's benefit and see if this. So, where is it? Where did it go? Where did it go? Oh, come on. Come on. So you're talking about this.
Yeah, that's right. Sorry, multivitamin for healthy innovation. Yes.
Multivitamin for healthy innovation. It's like this. I do innovation coaching, and coach plays more like a doctor, right? This is a generic one for innovation, and I've actually covered multiple different things, tools that I use for. Actually, let's see if I can pull up something here for you. Oh, God. Sometimes the machine is just too slow. Or maybe the graphic is too big. Sorry about that. Okay, so I talk about, this is actually the most recent book. I haven't seen my own copy yet. It was published last week. Vitamin A is alignment. Alignment between business objectives, business strategy, vision, down to the technology portfolio, down to the employee objectives. Entire organization-wise, the horizontal alignment and vertical alignment. We talk about horizontal integration, vertical integration. I think horizontal alignment and vertical alignment is also an important part. So vitamin A is around alignment. Vitamin B is about benchmarking. Benchmarking technologies, products, business models, talent, knowledge, whatever you have within your organization against the environment you're competing, or two, in context of the customer expectations, benchmarking. Vitamin C is having a chief engineer or a chief innovation officer within an organization that helps manage and build the culture that drives innovation. Vitamin D is about a dashboard of what is important to you, the key performance indicators. The vitamin E is about exploration. You want to pursue innovation, and if you don't have an exploratory mindset, it won't take you very far. So once you align the organization, you benchmark it with the competition, you have built your environment, you've got a chief driving it, you know what your success metric is on vitamin D, start exploration. That's vitamin E. Now, every time you explore, you may not succeed. So vitamin F is around failure. That's the vitamin you take when something fails. How do you accept that failure? How do you learn from it? And how do you go forward? And vitamin H is about the human aspect in innovation. How do you deal with diversity, leadership? How do you deal with ethical issues? In the end, innovation, like over here, I say, is an H to H. It's a human idea to human needs process. So vitamin H is around understanding the human in the entire innovation process. The vitamin K is about managing knowledge and managing talent that generates the knowledge. So I call that as a vitamin K. And finally, the vitamin PP, it ties your purpose and profile. Your purpose as to why you're doing all this. Remember, we just talked about the why piece of it. And profile is how you actually go about doing it. So that's what this whole book is about. It's not a medical book, but it's written as if a doctor is prescribing various vitamins to the patient. So when I work with an organization, I say, you are deficiency in vitamin D, your dashboard is improper. You have vitamin K deficiency, you don't know enough to do something like that, and vitamin H deficiency because you don't understand the humans that are playing in there. So I can go as an innovation coach, look at what vitamins are short in your organization. How do we bring those vitamins to the organization? That's what this book is about. and it's written in a business fable form. It's just a conversation that goes on between coach and his client in a conference room. So it's not a traditional management or an engineering book. It's just like a movie, being played with multiple characters in it.
Thank you, Dr. Singh. Any other questions, anybody? If not, thank you very much. We really appreciate your taking the time to give this excellent talk.
Thank you, Professor
Thank you
Raju.
so
Thank
much.
you for your time. Thank you, students. I hope you enjoyed it, and I hope there are people out there who will watch the video later on and will get some traction on the subject. But even if you're not into NDE 4.0, please get into Industry 4.0 and work like a part of an ecosystem and let everyone grow in this data-rich environment.